instrumental style. Instrumental style. Instrumental style.
There we go. Audio's good. Alright, iron is on. We got a PCB here. Let's check our other cameras. Pixel 2 is looking good. Alright, is it me or is that not quite in focus? Let me fix this camera real quick. One moment. Let's have you focus there, and then let's do manual focus. Alright. So that should stay in focus on that. Alright, let's get our... Look at that. Alright, so today, let me, let's see here. Alright, I'm going to pull this out and put it over on this screen. There we go. That way I should be able to see anyone who does any questions. And I can leave that alone. Alright, so I should be able to see that screen. If you have any questions, feel free to put them in chat. Say hello. Let me know you're here. Today we're going to be building this Geiger counter kit that I got on Amazon. It was incorrectly listed, so in the doobly-doo I've put a link to the original creators AliExpress page, so you can take a look at that. If you have any questions, feel free to interject at any time. Otherwise, I am just going to get started. This is not going to be one of my normal workshops where I teach soldering so much as we're just going to build this together. We're going to have fun making this. So let's see here. Let's look at... Alright, let's get some solder out here. We got the iron on. We have the correct tip on there for this. Oh, look at that. We've got ourselves a little Geiger counter tube. Now, I don't think this is going to be the world's best Geiger counter by any means, but it should be fun. Let's see here. That camera view is a little too... Let's see if we can bring that in a little bit better. There we go. Alright, so we've got some big parts here. Looks like power, an audio cable for some reason. USB cable, some standoffs. I will also be looking at not receiving enough video to maintain smooth streaming. Jeez. Why not? I'm on fiber. I'm physically plugged in. I'm not using the Wi-Fi. Alright, well, we're going to go through the BOM, which came with the kit, and we're just going to be placing parts in and chatting, so if you have any questions. Alright, going through all this, I kind of want to do the resistors first. But this is organized in an interesting way. Copper pillars, yep, U80. There's the 2555 timers. Huh. Alright, so given the way this is laid out, I think I'm going to go by the order they have on the BOM and not my usual method, which would be to get these come now. Sorry, the legs on this tripod are wobbly, to put it mildly. Kind of want you to have the same view as the other camera. Pretty please. Maybe just for me. Oh, come on now. I need a better tripod. You know what? We'll just go to a different view. Alright, so we're going to start with two capacitors that are 100 microfarad 16 volt capacitors. They are polarized capacitors. And they are in position 1. Which I'm just going to open with this little knife. C1 and C2. Now these are polarized capacitors. So that means they have a negative and a positive. A positive is the long leg, which is a pretty common convention. And we can see, let's do a close-up view. Where are we on the board? Over there. Alright, so we need to come. There we go. So here's where C1 and C2 are going to go. We have a positive and a negative indicated. The other major sign on these is that we have this large negative stripe. So in addition to the long and the short leg, we have this lovely negative stripe, which we're going to make sure is opposite of that positive. Let's switch back to, there we go. So we're going to put these in, we're going to spread the legs out a little bit. Tricky thing here, positive is on opposite sides on these two. So it's on this side. We've got positive on this side and positive on this side, which means two negatives are facing each other. Clean our tip. I'm going to rotate this for a little bit easier access. We're going to do just the Goldilocks amount of tinning, and we're going to populate these boards. There we go. Of course, my cutters are underneath that. We're going to come back and we're going to trim these nice and smooth. And normally, I like to do my projects like if this had a circuit diagram and all of the parts labeled in the packaging, I would start with the lowest height parts and build my way up. But the way this is packaged, and since I'm doing this hopefully so some of you all can do this yourself at some point, I'm just going to do it the easiest way possible, which is to follow this bill of materials here, which says we're going to go from left to right, top to bottom. So we have our C1, C2, and then which is in let me switch to the, there we go. So we're following our BOM, which is labeled here, all of our parts, and then these are in different bags. So these are our first ones. That's one, and number two. So it's going to go like this: 1, 2, 3, 4, 5, 6, 7, 8 down here. So we're just going to follow that because that'll be the simplest way to know that we're getting the right parts every time. And I want to make this as easy as possible for anyone following along themselves at home. Alright, so and with that being said, we have some non-polarized capacitors that go in next: C3, C23, C24, and C66. So I'm going to cut open their little spot with my X-Acto knife. Where did I put the tweezers? There they are. And I'm going to get these out of their thing, and we're going to find homes for them. Let's switch to our close-up view. So let's talk about how these are a little bit different. We can see we have (104) on there, like the surface mount resistors. The last number is the number of zeros, I believe. Don't quote me on that. Anyway, these don't have a long or a short leg, and they don't have a stripe because they're non-polarized. It does not matter which direction we put them in. So let's find their homes and put them in their place. So let's see here. We got C3. That's well, there's C23. That's one of them. C3 is where? There's 5. There it is, C3. I'm going to just put them in place. I'll try to do this on camera. C23 we found. C24 we need next. There's 21. Usually they're near-ish each other. Nope, it's all the way over here, C24, so we're going to put that in there. and C66, which is all the way over here. Alright, so we're just bending the legs over. Now that we have they're all in place, we can see where they're going to be sitting. It's time to pop them in. So I'm just going to put these in their place. There we go. Easy. Oh, come on now. So what I've, as if you've seen it in my other workshops, you know, I talk about how solder wants to stick to the hot part, which is the iron, and that's what it did right there. It stuck to the iron. It did not want to stick to the pad or the part. Always hold the edge of these when we're cutting them so it doesn't go flying off. We're having fun, and it's a lot less fun when we hurt ourselves because a piece of metal flew in our eyes. Reminder, we want to cut these fairly close to the ball. We don't want anything that's going to stick out that might hit a neighboring pin. We also don't want to get so aggressive that we cut it all the way down to the PCB and it no longer holds. There's a nice balance between these. Alright, so now we have some two more capacitors, C5 and C22. They're also going to be these ceramic capacitors, which are non-polarized. There's one, and there's the other. 22 we saw was over here. So I'm going to put that one in right there. And C5, where is C5? Oh, it's right over here. So we're going to put that in. We need to spread the legs so it doesn't fall back out. Once we have it in place, we're going to pop those in. There we go. Easy peasy. They get stuck on this mat. With any kit like this, we definitely want to trim as we go because this densely populated, it'll begin to be a real pain in the butt to manage all of those. I'm gonna I think there's just a little extra on there. I'm gonna take that off with the dry iron and trim that a little bit better. Oh. Alright. What's this? More capacitors. But these are a nice cheerful blue. Blue capacitors are my favorite color of capacitors. I like them. If you've ever done one of the Mr. Blinky Bling Blinky kits at one of the conferences, we have these adorable little blue capacitors. They are super cute, and I make the hat order the correct ones. No ugly tan ones there. We get the cute blue ones. Alright, so we're looking for C6, C7, and C20. Alright, it's hard to do this upside down. Let me, there's 6. There's 7. And that's weird. C20 is a different footprint. Well, we're just going to stretch it in there to fit. It's not going to fit quite the same. It's going to stick up a bit, but what else are we supposed to do there, right? Now, if you have a PCB clamp or vise, that makes this sort of assembly easier because it's not going to wobble as much, but then you have to turn it up right side up and upside down quite a bit. Is that all of them? Yeah, that's all of them. I'm going to put a little bit more on that one. There we go. We need the appropriate amount. Yep, see, that's what I mean. A little bit extra on there. We don't want that. I'm not seeing any questions. If you've got any questions or comments, please chime in. I am keeping an eye on the chat. We're just going to try to bang this kit out and show you how easy it is to put this together. At some point I am going to put together my how to solder workshop so you can follow along that as well. Alright, so now we're on on part number 5, which is another capacitor. 270 picofarads. And let's see here, you are C21, which is, I recall, is right over here. So again, it's non-polarized, doesn't matter which direction it goes in, just want to put it in, spread the legs like that, and you know what, let's do this one on the close-up camera. There we go. So you can see the action we're going to do. Just like that. There we go. Perfect little solder balls. Now we're going to come in and hold this and trim nice and close, but not too close. Come in on this side. Look at that. This is still not a good view. Alright. So we've got a whole bunch of capacitors on board. It's time to do something different. We're going to do some diodes. We have 3 diodes. These are not light emitting diodes. They are 1N4937 diodes, which is, as I recall, a pretty common part. And they pre-bent the legs for us, probably so they could get them in these little plastic pouches. Now, diodes are like little turnstiles for electricity. They only allow the electrons to go, the current to go in one direction. So we need to know what direction that is. So let's look at the close-up camera so that we can see what we're doing. Make sure we do this correctly. Now it's not super clearly labeled here, so we're going to take a look at that, because this is one of those spots that might be in the kit that I think might be a little bit tricky. We have D1, 2, and 3 over here, but what they're actually for are these pads here. They're just as close as they could get it. There's no room due to the capacitor here for that silk screen. So the reason we know that these are diodes is we have these white lines on each side, which are going to indicate the orientation here. We also have a white line here. So this white line on this part is going to line up with this white line on this part, vice versa for all three of these. And then this R33 is going to be for this resistor here. So that is how to read the PCB. When it gets a little bit confusing, this is one of those things you'll start to look for. Is there a cluster of numbers, indicators near something that doesn't have any? And then, so we have D3, 2, and 1. Now the nice thing is 1, 2, and 3. All three of these diodes are the same. It doesn't matter what direction, what order they're in. I'm sorry. It does matter what direction they're in. So we're going to put these in correctly. So let's do that real quick. We're going to put this one in with the stripe going that direction. This one's going in with the stripe going in this direction. And then this last one, same direction. If we can fight with it till it gets in there. There we go. We want to get them nice and close to the PCB. And then we're going to bend the legs out. And now we're ready to flip this over and solder them. So let's see if we can do that on the close view and see all of them. There we go. Still no questions. Feel free to ask a question if you got one. We're just here putting this together. Never done this particular kit before. Never built a Geiger counter before. It just seemed like a fun project. There we go. And once again, we're going to hold these down with our fingers so that they don't go flying when we cut them. We want to trim them nice and close so there's nothing that can catch on anything. So this one's a little bit long. There we go. Now it's not sticking up so bad. The same thing over here. We're just going to hold that down with a finger and cut it nice and close. That way there's nothing that's going to short over here. We need to be careful. Consider that. Alright. What's next? We've got our diodes in place. We've got a bunch of capacitors in place. Are there any more diodes? Yeah, there's a couple of light emitting diodes. Now these operate in a very similar manner to the other diodes, but they have the additional benefit of releasing some light as they do their job. So even though we're using these as a source of illumination, they're not like light bulbs, which we can just plug in any way we want. These are a diode, so we have a positive and a negative, a long and a short leg. Long leg is going to be the positive, usually. But we're going to, oh no we're not. My multimeter is not within reach. Normally I would always test it with a multimeter. I recommend that, but it's not worth getting up for. So we're looking at diode 23 and 24. Here's 24. We'll put the long leg in the plus. short leg down there, and do that. And now we have, where's the other one that died? 23, D23. Looking for another circle footprint. Oh, there it is, all the way down here. Alright, so we have two. Now, you may notice that the LEDs stick a little bit on the way through. There's little standoffs embedded in them. Those are designed to so that you can you know, stand off the LED so it can sit up above the PCB. I find that to be fragile, and I avoid it myself, but some people like to do that. Alright, I'm not liking that joint. I'll let that heat up a little bit more. There we go. Let's trim them real quick. Still no questions. Alright, so now we have a couple of light emitting diodes that are going to indicate things. Keep knocking that capacitor over every time we flip this over. Looks like we have some IC sockets next. These are chip holders. And the benefit of using them is that we can pull the ICs out if we need to without a whole bunch of hassle. So should the IC be damaged, should it experience an overvoltage or something else, we'll simply be able to unplug it and plug a new one in. But these do bear some discussion, so let's look up close at them. Let's find a spot. Let's find one of the, yeah, alright, so here is a spot for one, IC1 right here. We see we have a little notch here, and we see we have a little notch here. There's no notch on this side. You can see there's a little 8, but there is a notch on this side. We want to put the notch in like that. The notches should match. The notches are very important. They're going to indicate where pin 1 is on all of these. Now, when I put these in, I like to bend a couple of the pins over. Just I'm going to do this corner over here, and then I'm going to do this corner over here. And the reason for that is that holds this in place and doesn't let it fall back out. So let's switch to the wide view, and we're going to do that again for the other two. Again, we've got a notch on this side this time, so we're going to make sure we have this correct. And then, because if we let go, there's a chance that it'll fall through, we're going to bend the opposite corners, so that'll hold that in place. And then we have one more over here, and once again we're going to line up that notch. All of our little legs, seems like a couple of them are bent. That one's holding itself in place. So here, let's go back to the close view and I'll show you how we solder these. There we go. We've got one there. Once again, we want to have that Goldilocks amount of tinning. Put the tinning side down, and we just want to work our way down the pins. When you get really good at this, it's nice and quick and easy. But don't hassle yourself if it doesn't come naturally at first. This is something that takes a little bit of practice, but you'll get it nice and smooth. If you're following along at home and I'm going too quick for you, just go ahead and pause until you get done. It's no big deal. Well, that one did not want to go. The tip is getting real oxidized there. We're going to come back over here for this one. So since I cleaned the tip there, I'm going to re-tin it, and then we're just going to put the solder on the other side, make it work to get to the pad and the part, and go across the pad and the part and work to get over to the heat where it wants to be in that on that soldering iron. Look at that. So now we have those. Let's switch back to our wide view. We've got a bunch of those sitting there ready for their ICs. Now we've got some headers. Some pin headers we're going to be putting in place. Let's get all of these out. So we have some standard jumpers. That's what these are. Let's take a, we'll go to the soldering only. There we go. You can see there we've got ourselves a standard little jumper. And this is the header they go on. There's a long and a short side. We're going to be soldering the short side is the side that goes into the PCB. The long side is where these slide on. So these will slide over these pins and form a temporary jumper. These are usually used in circuits like this for configuring options, enabling and disabling things. So for example, and I don't know if that's part of this kit yet because I've honestly been kind of lazy about reading the documentation on it. But if, for example, we wanted to enable and disable the onboard speaker, this would be an easy way of doing that, and cheaper than a plastic switch. So let's see if we can figure out where they go. J1, J4, and P100. So P100 is right here. Now these have really thick pins, so they do not like to be bent, I've noticed. So I'm just going to put them in one at a time this time. So P100 is in place. And that's probably just a jumper to say whether it's getting power from this header or the USB or whatever this is. This might be a power connector, I don't know. We'll figure it out when we get there, won't we? Alright, so J1 and J4, where are those at? We have J4 over here, which is labeled test. So it might be for testing the circuit. I should note that I do not have any radioactive sources to test this with. But I also kind of want to get the LCD add-on for it and put that on here as well before I get that crazy. Or get that involved, I should say. J1, that's it, that's J4. Now we need J1. Where's J1 at? Don't all shout at the screen at once. There it is, right there in the middle. Let's see if I can get this in place. I'm going to hook it with my fingernail. Use some tension to hold it in place. And I'm also going to put, there we go, I'm going to rest it on the end of my tweezers so it gives it a little bit more lift, holds it firmly against the PCB. Beautiful. There we go. So all of these are in place. I'm going to put the jumpers on them just so I don't lose them. And I'm not planning on applying power to it just yet anyway. Not until I take some time to read more of the documentation. There we go. So we have all of our jumpers. Now, this particular jumper is crooked. These two are straight, this one's crooked, and I'm going to show you how to fix that just because I'm annoyed by it. So I'm going to hold my hand here, and we're going to put the heat on both solder pads right here. And because I was holding it with my hand, I was able to steer it up to straight vertical, and it's still soldered in place. So that's just a quick tip on how to make something a little straighter. And because we had the jumper on there, it did not burn anything. Whereas if you do that with just the pins conduct heat and would burn your fingers a little bit. So you got to ask yourself if it's worth doing it that way or not. Alright, so we have our pins in place. We have one more header. This is a 3-pin header. Let's get that out of its little bracket. And it is going to go over here. It says P3. And just to provide a little bit of extra height, I'm going to set it on top of my tweezers. And then we're going to tack it in. Now, my tip's getting oxidized. Your tip gets oxidized, you're going to have a not fun time. So feel free to clean it often. I use the brass for cleaning it more than the sponge because the brass takes less heat out of the iron. And heat is the name of the game. Look at that, we're making rapid progress. We got a whole bunch of stuff populated, and it is time to do, is that an inductor? Looks like, yeah, we got an inductor. That is a funky looking inductor. It looks like a resistor. And looks like a resistor, so I'm going to yeah, that looks, I mean, tell me that doesn't look like a resistor to you. Alright, I'm going to just see if I can't find inductor looks like resistor. Ah, yes, it's an axial inductor. How to visually check the difference between axial inductors and common resistors. They have one fewer color band and tend to be pea green or even cyan. Although there's a bunch of resistors in here which are similar, they're blue. So I guess the other way we could tell Let's see if this detects it properly. Let's see if this tool, what this says about it. I don't know if it'll detect it or not, but we'll put that in there and see if we figure it out. It says unknown or damaged part. Let's see if I can get the two pins in the same. Yep, it shows it to be an inductor. So that's cool. Put that back over there. Now, as an inductor, it does not have a polarity. L1. There's L3. There's L1. So we're going to put it in here like that. Right there next to the first two capacitors we did. And we're going to bend the legs out just like that. And once again, clean the tip. Soldering with an oxidized tip is miserable and slow and frustrating. It doesn't work. Leads to bad solder joints, so it is good to be in the habit of just cleaning it as you go. Anytime it doesn't look as clean as it could be, we just take a moment. Do that. Alright, so that inductor is in place. We've got another inductor, and this is going to be a much bigger one. Look at this beefy inductor here. This is L3, and it's easy to find its spot. Got a big spot right here. Look at that. So here we're going to do the same thing where we just, let me turn this so I can get the iron in there a little bit easier. I'm going to tin the iron, tin side down. And we want to make sure we get a really good connection to the whole pad. And we're going to definitely hold on to these as we trim them. These thicker posts like this, they will leave with a little more energy. So we want to be careful. Look at that big inductor in place. So it's a little bit crooked. There we go. I think that's a little bit straighter. Just heated up one of the pads and put some firm but gentle pressure on there. Alright, what's next? A beeper. We're going to put in a little doot to make some noise. This is what's gonna make that famous clicking sound when it detects radiation. And since I don't have the LCD version, which is what I thought I had ordered, we need to take a closer look at this. So it's going to go or is that upside down? There we go. LS1. So we notice we have a positive here. There's a positive and therefore a negative. We have here a positive indicator on this label which says remove seal after washing. I don't plan on washing this, but we also have a long and a short leg. This one is longer, this one is shorter, and the long one is once again positive, which is the usual case, but again, not always. So we're going to put that in, and because that short one is so short, it was quite difficult to bend that in place. Here we have an oxidized tip. You can see that black band and all that. So I'm going to clean it and then see how it's, there we go. The solder wants to stay on that hot iron. So I'm going to put my finger over the top of this, trim that nice and short. Same on this side. I'm going to cut it right here, but I'm going to keep my finger over the top so it doesn't go flying. And look at these lovely connections we have. Right here and here. So let's switch back to our wide view. And I think it's safe to remove the sticker now. Look at that. And that sticker's probably there for any part where they clean the board with like isopropanol or something like that. You don't want moisture getting into that hole, into the resonator cavity. Alright, so we've got our beep. It's time to put a power port on there, or some sort of plug port. It's labeled P2, so that's why I'm thinking power, but it could just be a regular. Oh, you know, I think it is for power. Well, it's got a positive and a negative anyway. And it's this nice part here. Let's look at this up close because it's very much going to matter what direction we put this in. So this is going to sit here at P2. And here's what it looks like. You can see we have screws on the top. We have access points for wires to be inserted into. And it's very important that we put this in the correct way. It needs to be this way with the screws on the top and the ports facing out. If we put it in backwards, this way, well then it's going to be very difficult to insert the wires in on this side. So we very much want them to be on this side, where these cutouts are lined up with these notches. So that is an important thing we want to consider, and of course it does not want to stay in. And again, this is why I usually go the route of shortest to tallest component, but I didn't design this kit. Alright, so I'm going to hold that part in place with my X-Acto knife, and I'm going to come here and just, there we go. It took it a second for the solder to pop it down onto the pad, but once it did, voila. And again, this has to be in this orientation with these ports on the outside, with these notches lined up with these indicators on the PCB. That's an important part to consider on this one. Alright, next is another power, P4, I think. Or no, what? No, not P4. It says P3 here. That might be a mistake. That might be a mistake on the board, because P3 is over here. Oh no, I'm reading the wrong part of the bomb. I should have used a marker to mark off what I've already done, because a problem exists between the keyboard and the chair. Not with the kit. Alright, so it is P4. And that is this power connector. And once again, it is keyed. So we're going to put it in so that it fits there, facing outwards. And this is going to require more solder because it's so large. So let's put this up close. We're going to clean. Now here we're going to do more tinning than I did before. So we're going to put a larger amount of tinning because we're making a larger amount of surface area, and so there we go. The surface tension is going to be a little bit different because it's so large. And we just want to make sure we get the edge of the iron, not the tip of the iron, because we have so much surface area we need to deal with. Look at that. There we go. Now we have our power connector correctly hooked up. Let's switch back. Still no questions. Well, if you got a question, type it in. I am watching the chat. It's time for some transistors. We have some NPN transistors. There's two main types of these transistors, NPN and PNP. And it has to do with how their gate works to trigger the switching operation. But I'm not an electrical engineer. The nice thing is it's Q1, Q3, and Q4, so we can find those hopefully pretty quickly. This is Q1. Oh, it is probably instructive to look at this a little bit closer. So let's go to here. We're looking at Q3 here. And here's the transistor itself. Now we notice if I put another one here, the other side, we have a curved side here, and we have a flat side. And the flat side is where our indicators are. And then we have a 1, 2, and a 3. And there are 3 legs here. So which one is 1, 2, and 3? Well, we're going to line it up with the flat side. This one is going to be, so the flat side is going to be against on this side. So we're going to have this straight up and down right here in a moment. And the way we're going to put these in, this is going to be 1, this is going to be 2, and this is going to be 3. So the way we're going to do that is by bending 2 forward a bit. Like such. So you can see it's bent forward a little bit. We're going to put 2 in there and 1 and 3 in like that. And then we're going to push it all the way through as far as we can go down. And now it's important to see that we have the flat side and then 3 back here, so that when we flip this over, there they are. And we can do all of them real quick. Maybe a little bit more on that one. And then we're going to hold this down, trim the legs. We want to make sure we don't have any of these laying about to be little bridges. Alright, let's switch here. Alright, so let's put the others in. That was Q3. I need to find Q1. That's Q2, that's Q1. So Q1 we're going to put in, we got to bend 2 forward. And we're going to push it in place, just like that. And then we're going to bend our legs out, just like that. Again, we need to have this flat side with the flat line. And we got one more. We have Q4 to find. And Q4 is all the way over here. We're going to put that in and push it forward. And now we can solder all of these connections. There we go. Now it's time to trim them up. I like to put these in the trash right away. If you don't have a trash nearby, if you can use a disposable cup or some other small disposable container you're not going to eat out of again because this solder has lead on it. You don't want to ingest that. Alrighty. Bum, 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 bum. We've got those. Alright, it is time for Q2, which is another NPN transistor, but it is a different type. So it probably has a different threshold than the other three. Alright, so we're going to bend that pin 2 out. And it's right here. So we're going to line up the flat side. See how we have the flat side lined up before we push that down. The flat side lined up. There we go. And then over here. And it's time to there we go. Easy peasy. Still no questions or comments? Is my audio going out alright? Yeah, we'll check later. Alright, look at that. We are making serious progress. We've got quite a bit of this assembled. Meow. Well, my cat needs to say hello. Oh, come here, darling. Oh, come up here. Oh, oh. It's not a live stream if she doesn't come say hi, is it? Oh. You need some lovins, do you? You need a little bit of attention. Has it been, what, half an hour since you've been petted? Well, it's been almost an hour. Almost an hour I've been at this. Yeah. Yeah. Oh, you poor thing. You can't be on my lap, darling. Go entertain yourself. It's not like you don't have plenty of toys. Alright, we are now on resistors. It is time to do some resistors. We have two 33K resistors, which are going to be R1 and R2. Now, this is where I would normally start the assembly if I were doing this. Now, let's look at these up close. These have stripes on them, and they tell us what value they have. I just flip them around so that they're the same way. There we go. Orange, orange, black, red, and I think that's another black. And usually the last one is the tolerance. And I'm not sure what that decodes to off the top of my head. I always look that up, or use a multimeter. But we need to find R1 and R2. And R1 is right there. Oh, dropped one of them. Where did the other one go? Oh, man. Oh, one moment. Why? Oh, here we go. Where is R2? R3, 20. Wait a second, there's two R1s. Oh, that's R11. It's a good thing I noticed that. That's R1. Alright, so let's take a closer look, because that's a bit of a trap. Let's zoom in here. Because I wasn't reading very clearly. This is R5, R11, not R1, R7. R1 is actually here. So that is the mistake I just made. So hopefully you don't make that as well. R1 is there and R2 is right here. So we can put R2 right there. And look at that. And let's do these up on the close-up view. You can see what we're doing here. There we go. There's all three of them. I mean, all four pads in view. There we go. See how we wait for that solder to pull itself down. It's worth spending just a little extra time on there with the iron. Oh, I forgot to trim these. To let the heat soak all the way through that connection. Just a little extra time, a little patience with the iron will end up saving you a lot of time going back to fix things. Alright, so we've got R1 and 2 in place. What have we got next? R3 and R23. There we go. So let's find homes for these. R3 is where on here? R3 is there. And R23 is right over here. So there we go. One went over here, one's over here. There we are. And we got to remember to trim our little legs. See how close that is to that over there. I'm going to get a little more aggressive and trim that off a little bit more. I just want to make sure that they're not touching. Look at this, it's starting to look pretty good now. We've got one more over here. R4 is a 3K. So where is R4? It's right over here. Oh, hey, darling. How's my kitty? Oh. It's just a hard life, isn't it? Meow. There we are. Trim these. Now we've got R5. It's 100K. R5 is on this end. And there's no particular polarity, and I'm not being super picky on what direction I put the stripes on these. If you want to be picky, you can. It's entirely up to you. Make them all line up in the same orientation, but the circuit doesn't care. Oh, yeah. It's just terrible, darling. Oh, it's just terrible. There we go. Line that up a little bit better. Oh. Poor kitty. Meow. Meow. Alright. We just did R5, right? Yep, R5 is in. So we're doing R7, 8, 9, 10, 11, and 33. We got a bunch now. Let's get them all out. Look at that. 1, 2, 3, 4, 5, and 6. Let's see here. 7 is right here. I'm going to bend those legs out. 8 is right next to it. And again, I'm not being picky with the orientation on them this time. 9 also goes in there. If I had to guess, these are for the 555 timers. But I'd have to look at the schematic to really know. I'm just guessing at this point. R10. Alright, that's there. R10, R11, which comes all the way back over here, which we found earlier by mistake. And then R33, which is '32, '34, '20. Oh, it's this one over here by the diodes. It's the one over by the diodes. Alright, so we got a bunch of these to do. Let's put these up on the close-up. There we go. Now you can see how we're going to clean. We're going to use just the right amount of tinning, not too much. In fact, that's probably a little too much. There we go. And we're just going to very gently boop all these in place. Notice how I'm using the edge of the iron, not the tip of the iron, touching both the part and the pad. This is one of those things where technique makes or breaks your experience. If you've got the wrong technique, this is going to be miserable for you. If you've got the right technique, this is going to be easy for you. So just like that, now we need to trim them up. So I'm going to hold all of these and just walk down the line, trimming them nice and close. Look at that. I'm going to turn it around and do the other side. Alright, now I need to pick all of them up. Because these can cause problems if they're around For one thing, they make a really nasty sliver. For another, if they're stuck somewhere on the back of the PCB, they can short things together that aren't supposed to be, damage your project. We don't want to spend a couple hours building something just to break it because we're lazy about cleaning up after ourselves. Alright, we got a couple more resistors to do, but we're getting closer. Look at this. Good chunk of this is done. Alright, let's we have R16 and R24 now. Alright, so R16 is right here. I'll put that in. That was easy to find. R24 is right over here. So I'll put that in. Right down there. Look at that. We have to be real careful with this. In fact, I want to get up close for this one. I want to show what the problem is. So the problem is this right here is super close to bridging here. So if we're not careful, we could end up with if we trimmed this out here, we'd have a little bit of extra stub that could be bent over and accidentally short. So we want to be extra careful when we cut this so that we make sure that there's plenty of room and there's nothing in there that's going to cause problems. That's one of those gotchas you want to watch for. And when you're bending your legs out, you want to make sure that you don't accidentally bend them across another joint, which may then conduct enough heat that it melts itself to that joint and forms a nice little thermal bridge, or a nice little electrical bridge, which is definitely not what we want. Look at this. We are getting really close. Just a few more parts remaining. Alright, so we need to do R18 now, I think. No. R17, 19, and 20. I'm getting ahead of myself. $17, 19, and 20. Alright, so 20 happens to be right here. That's easy to find. Get in there. Alright, so R20 is in place. So 17 is right here. And 19 is right over here. look at that. So now we can pop these in place. Oh, that didn't get all the way clean. There we go. It's okay to aggressively clean your tip. It will make your life easier. It's one of the reasons why I do it so much. There we go, look at that. Now it's time to trim. And once again, we're trimming to make sure that we don't have anything that will cause us any problems in the future. Alright. The good news is it's going to be easier and easier to find spots because there are fewer and fewer spots remaining. Alright, so R18 is next. And we know where that is. We were just looking at it. It's right here. And it popped out. Frustrating. There you go. Get in your little home. And solder that in real quick. In fact, let's do that on the close-up. Still no questions. Feel free to ask questions if you got them. Just say hi if you want to. Let me know you're here. There we go. I'm going to come back and trim that a little bit closer. Just not happy with how that looks. There we go. We got one more resistor, and that is R32. Well, one more standard resistor. We have a special resistor coming up, which I'm kind of looking forward to showing you. It's a variable resistor, also known as a potentiometer. Yeah. So this is R32. I'm not seeing an R34. Did I miss R34? No. There's an R34 spot here, but I'm not seeing an R34 in the bomb. Huh. Did I screw up, or am I just not seeing it? Well, here, let's switch to close-up. I'll show you what I'm looking at. Right here, we have R32, which is right here, the one we're going to solder in a moment. R34 labeled here, but there is no R34 in the bomb, so that is probably intentional. Just something to consider. Let's solder that in real quick. Happy little resistor in its happy little home. There we go. Now we're going to trim that off. There we go. In the garbage. Now we're getting to our fancy potentiometer. And I use some of these with my work. Take a look at that. So let's look at this up close. We have some standoff legs here, because sometimes they're mounted sideways, like such. We have 3 pins here. They're helpfully labeled 1, 2, and 3. And then we have a knob here that we can rotate. So I will rotate it so you can see, there it is. And that adjusts where pin 2 is between pin 1 and 3. This is a high precision type, so it is capable of better resolution than some of the larger pots you may be familiar with. And that is going to go over here with R1 100 here. But I want to make sure I have this in the correct orientation. Alright, so we're going to take a look at this. This is right here, R100 is what we're working on here. And I'm going to actually turn away from the chat for a moment and look at the wiring diagram, because I want to make sure I get this correct. So I'm going to take a look at the schematic. Zoom in, please. Thank you. Where is our potentiometer? It's broken down into a couple of different parts. We have the inductor. Oh, there it is, R100. So, does not have pin 1 labeled. That is not super helpful. Both those go to ground. Alright, so let's take a look at that's the tube specifications. That's how to calibrate it. Oh wait, it has a picture of R100. Excellent. Alright. This is why we check the documentation. So R100 is going to be oriented this way. There we go. So our adjustment screw is going to be on the opposite side of the label. The label's over here. The adjustment screw is going to be up here. It's also the same side as this stripe on this nearest diode. So this, yeah. So and then we're going to assume that this little notch here indicates the turning surface. So that, I think, was a pretty useful little detour to make sure we got that correct. So that, looking at it from this view, the knob goes on the opposite end from this silk screen on this side. So let's solder that in place. I'm going to try to get it so that it sits flat. And you know what? Let's look up. We'll go close on this one. You can see how we do. Again, just the right amount of tinning. Put that touching part and pad. Make the solder work to get where it needs to go. And that nice hot iron where it wants to live. Yeah, beautiful. Then we're going to come back here and trim these as usual. Switch to the large views so I don't have to hold it in that it's a really small area of focus on that camera. And I would like to just pick it up and go. There we go. I'm going to trim a couple of these which are not quite trimmed enough. There we go. So, got that. Now it's time for a switch. Power on and off. Switch 1. And that is going to go over here, I'm pretty sure. Yep, switch 1. We are, once again, when I want to make sure that we have the switch facing out. If we put it backwards, it's going to run into this LED. How are we going to hold you in place? Yeah, you're going to fall out on me, aren't you? Let's see, are we on the right camera? Yeah, we're almost there. There we go. There we go. So we have 2 supports on each side as well as the actual switch pins. The support ones are going to require just a little more solder. And we're going to do those first. Hold it in place. This undergoes a lot of mechanical stress, so they have extra components there to hold it in place. Remember, when we solder this together, the solder is forming both an electrical and a mechanical bond, and we need to make sure we're dealing with both of those appropriately. Now we have our tube holders. They're going to go here, here, and here. These are a larger part, so they're going to sink a lot more heat. They're also metal, so they're going to conduct that heat. So when you're doing this at home, you want to be cautious both of your fingers and your table top. They also have an orientation. Let's look up close at them. There's a tab there. I'm going to put one upside down here. So this tab right here, if we put this in incorrectly, so if we were to put that tab in on this side here, it's going to block the tube from being able to go in. We're going to want to make sure that we put these in correctly, the tab on the outside. We're also going to want to make sure that we size these to the size of the tube we're using. So now I need to remember where I stuck the tube. There it is, and make sure we're using this. Yeah, so we're going to be using this size tube. So we're going to be putting these two in. I'll put this one in just for giggles, but it's not going to be used. I'm going to use the back side of my tweezers to bend these so that they hold themselves in place a little bit nicer. And I'll show you a close-up of that here in a moment. There we go. Let's look up close. There we go. So you see I've bent these out so that this stays flat on the PCB. We're going to watch that solder flow, form that thermal bridge, and then we're just going to fill it in. Same thing on this side. Look at that. So I suppose we could put the tube in. There's a positive and a negative on the tube. There we go. So we're going to want to put the positive on this side, the negative on that side. This does not quite fit. There we go. Kinda. Kinda, sorta. Alright, tube holders, the headphone jack. Alright, let's put in the headphone jack. This is going to be a little more complicated part, is it's got several ends in it. It goes over here, the only place it can go. And I am once again going to use my tweezers to hold it up so it doesn't fall down. And let's get this. Yeah, there we go. So there are 5 connections we need to make. There we go. I want to get it so those pins are all the way through the board. Doesn't do us any good. Now I am going to do this side first and then this side second. And then that allows me to pull this out and it'll now hold itself in place. So we're going to come over here, then we're going to come back to the first side, and then the second side do the inner pins, just like that. Around the world. Look at that. We've got ourselves a headphone jack. Alright. Now we need to put in our timers. We have two NE555 timers, and we're going to place them in the sockets we put in place for them. And they're going to go in IC1 and IC2. So that is IC1 and IC2, I think. Let's see. Yeah, IC2. So here they are. We need to pay attention again, so let's look close. Here is IC2. Notice we have our notch, and we have the notch on the PCB, we have the notch up here. We also have a notch on here. So this notch right here needs to line up with the other notches. If we look at the other side, see it has no notch. So all the notches need to be lined up, otherwise this will be in backwards and it will not work. We want to very carefully line the legs up like so. And you do want to be cautious with this. Make sure everything is lined up. Get it sort of seated like this before you apply any pressure. And just double check that all the legs are in a spot, because if one is out of sorts a little bit and then you press down like this, you can end up curling one of those legs up under itself, or breaking things, or just generally causing not fun times. So we want to be very careful with that when we're installing our ICs. We'll do a larger view here for the other one. Alright, so move it over here where we can see what we're doing. Once again, we have a notch here. And we have a notch right here. So this notch needs to line up with this notch, which needs to line up with the notch on the printed circuit board. And all of the legs need to be kind of, make sure they're in their spots. 1, 2, 3, 4. 1, 2, 3, 4. And then we can gently but firmly push it into place. And voila. Now it's time for the last IC, and we are basically done. The rest of this is all hardware installation. All of the soldering is done, so let me turn off my iron, which is on the floor. There we go. It's out of the way. I'm going to straighten up the legs on this with my fingers, because they were bent in a little bit. And once again, we're going to look for the notch, which is right over here. We're going to look for the notch on this. We're going to line it up. We'll make sure all the legs look like they're going into their right spots, and then we're gonna looks like this tube doesn't fit super well, but we've got it all lined up. Alrighty then, that is all that. The last thing we have in here is some hardware. which I'm going to cut out of this. Alright, and that's garbage. We'll throw that out here in a moment. Let's go through our bag full of stuff. We have some kind of protective shield. We have the headphone connector. We have the USB power connector. We have a header. And we have some more brass standoffs. Alright, I'm going to take a look at the looks like, yeah, J4 is just for testing. I am looking to see if there is a picture of this assembled. I want to see how they put this plastic together. I am not seeing I'm not seeing a picture of it assembled. Alright, well, I'm going to mess around with this for a little bit more, but since we're basically done with the instructions, I'm going to exit. I'll post a picture of this to Twitter when I figure out what I want to do with the hardware, where this goes. I imagine down here somewhere, but maybe it goes up here. I don't know. I'm going to mess around with it. Thank you for sticking around. If you have any questions or comments, hit me up on Twitter at Blenster. Big thank you again to CyberCityCircuits.com for sponsoring all of this fun stuff. If you need any sort of PCB assemblies or other work done, definitely chat with them. They are local U.S. manufacturer of electronics stuff. And yeah.